Hi everyone, welcome to our review video for test 1. So I've got here practice test 1. You're going to find this document on Blackboard, and I thought I'd just make a little video where I'm going to go through each of these problems and kind of show you how to solve everything. We'll also have some review time before the test in class, but this way if you'd like to review on your own, you have the video option as well. So I'm going to start us off on page 1 with problem 1, where they tell us to use the graph to find the requested information. Now, a couple of important details here. Grid lines are spaced 1 unit apart, and you may assume that all relevant information occurs at integer values. So none of the answers are going to involve fractions or decimals or anything goofy. So let's go ahead and start off by analyzing the graph and identifying its domain and its range. Remember that for the domain, you want to think of that as the span of x values. The range is the span of y values. Now, if you look carefully at the graph, you can see it's going to continue down to the left and down to the right forever. So there's no limitation on the domain. The domain as an interval would simply be negative to positive infinity. On the range, however, when we're looking for an interval of y values, it's true that the graph goes down forever, but it does not come up forever. In fact, if you look, this is the absolute highest that the graph ever reaches, and that has a y value of positive 3. So while the domain is unrestricted, the range is restricted, negative infinity up to and including positive 3. All right, for the next portion, they ask us on part C to state whether this function is even, odd, or neither. If it's an even function, that means it's symmetric right down the center, right down the y-axis. Basically, if you fold on the y-axis, the two sides would match up perfectly. That's definitely not the case here, so it's not an even function. Likewise, an odd function, that's what has rotational symmetry about the origin. Imagine if you were to rotate this graph 180 degrees. If it were to look identical, that's an odd function. That would definitely not happen here. If we rotate this thing 180 degrees, the entire thing would be upside down. It would look completely different. So it's not even, it's not odd. We're just going to answer here that it's neither of those things. Next, they ask us to identify intervals where this function is increasing or decreasing. Now, I'm going to mark up the graph quite a bit here, so I'm going to use do everything in pencil. That way I can erase and start over for the next problem, because I think it's really helpful to mark up this graph. Remember, for the question increasing and decreasing, you want to read the graph from left to right. So imagine you're starting way down here and you're moving to the right, and just ask yourself, when is the function coming up, and down, and identify those intervals of x values. So let's start with increasing. We begin here. We definitely start by increasing. The graph is going up until we reach this point. Notice that x value is over here at negative 2. So for this portion of the x-axis, from here all the way up to this x value, the function is increasing. It then becomes decreasing until we reach this value. So I'm going to mark the x-axis here, and it continues increasing until we reach this peak, this hilltop, this maximum. And so notice when I highlight that next portion of the x-axis, it's increasing from here to here. So let's write those two pieces of the x-axis as intervals. This first one would be negative infinity up to negative 2. Notice parentheses on both ends. And then it's increasing again from 1 to, what is that? 2, 3, and then 4. So from 1 to 4, it's increasing. Remember, increasing and decreasing intervals will always be using parentheses. Never ever use brackets for those questions. Now we're going to start over and look for when the graph is going down. When is it decreasing? So it's up, 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 up. Once I reach this x value at -2, it starts moving down until we bottom out at that low point. So mark the x-axis. That interval from here to here, it's decreasing. It's then increasing until you reach the x value of 4, and from there over, it's back to decreasing. From here over, the graph is going down. So those intervals, again, open intervals, use the parentheses, are -2 to +1, and then from 4 to infinity. And so there we've identified when this function is increasing and when it's decreasing. So I'm going to go ahead and erase those marks, and we're going to move on to the next question. So for the next part, parts F and G, they ask us to state the intervals where the function is less than 0 or greater than 0. This basically is just asking you when the function is below the x-axis or above the x-axis. So we'll answer the questions one at a time, starting with the below. You can see this entire portion of the graph is below the x-axis. So I'm going to mark the x-axis until I reach this point. So notice everything from -infinity up until I get to +3, this x value, everything from here to here, the graph is below the x-axis. So again, that interval is -infinity up to +3. Then it jumps above the x-axis, and then it ends back down below the x-axis. So that's an x value of 5 to infinity. Once you get to 5 and over, you're back down to being below. So that's 5 to infinity for the other interval. Notice it's above the x-axis for this little hilltop feature, right? And that little hilltop feature, that's going to occur. Again, I'm going to erase my old marks and make some new ones. Notice that's a pretty limited area or pretty limited interval when it's above the x-axis from here to here. So that's from +3 to +5. 3 to 5, it's above the x-axis. The last thing they ask us to do is identify any maximum points or any minimum points. So when we look at the graph, I'm noticing two maximums. We've got one here on the left and one here on the right as well. Simply state the coordinates of those points. -2, -1, and this one is at +4, +3. So again, when we jot those down, those maximum points were occurring at -2, -1, and again at 4, 3. Now, be careful here. It can be a little bit confusing. These are not intervals. These are points. So this is x comma y, x comma y. I don't use the union symbol here. I'm not putting two intervals together. It's just listing two individual distinct points. For the minimum, I'm just looking for the low point on the graph, and that's going to occur at this valley. Now again, that's not the absolute lowest point on the graph. For that, there isn't one. It's going to go down forever. But just any of these low points. Remember, maximums and minimums, we're looking for peaks and valleys on the graph. So the coordinates of this low point would be +1 and -4. And we'll go ahead and jot that down. +1 and then -4. Again, that's not an interval. That's an actual point, x comma y. So at this point, we've answered all of their questions. We've analyzed that graph. We're going to go ahead and move on to problem 2. So when you turn the page here, on number 2, let's see what they're asking us to do. We want to sketch a graph of the given function, identify each transformation that has taken place compared with its parent graph. And we're going to check all transformations that apply. If you check an item with a blank, make sure to fill in the blank. Now you could start by looking at this graph in your graphing calculator. So I'm going to go ahead and enter this function into my y equals window. So I've got the -1/3, and then in parentheses x plus 7, close it and square it, and then minus 2 in the back. If you want to look at the graph right off the bat, you can see this is a parabola shape. Let me get everything centered there. It's a parabola shape. It's been flipped upside down. Notice on a parabola, the vertex is normally located at 0, 0. For this vertex, it's been shifted 7 units to the left and down 2. And that's exactly what you notice from the actual equation. That's a horizontal shift of 7 to the left and a vertical shift of down 2. So, and you could do this in whatever order you'd like. If you want to go ahead and do the graph first, that's great. I would identify some key points by looking at the table. We've already talked about the vertex being here at -7, -2. So I'm going to go ahead and mark that on my graph, -7, -2. So that puts the vertex right here. At this point, I'm just going to look for a couple more kind of points that are just convenient, like this one at -10, -5. And then on the other side of the vertex, we've got one at -4, -5. So I'm going to go ahead and mark those. -10, -5, and -4, -5. At that point, you can go ahead and sketch in that parabola. This is just a nice U-shaped curve. Notice it's upside down, and the vertex has been shifted from 0, 0, 7 units to the left and 2 down. Let's go ahead and start stating all of these transformations. So start with the vertical shift. Normally the vertex is here. It's been shifted left 7 and down 2. So this is a vertical shift down 2 units. And that's all I expect for your answer. Just check that it's a vertical shift down and tell me by how much. At the same time, you have a horizontal shift, not right, but to the left. Again, normally the vertex is at 0, 0. This is shifted left 7, down 2. So it's a horizontal shift to the left, 7 units. The other reflections that you're noticing here, you've got a vertical reflection, right? It's flipped upside down. And also at the bottom, it asks if you have a vertical stretch or compression. That's determined by the multiplier that's out in the front of the function. In this case, it's a 1/3. Anytime that multiplier is less than 1, that's going to indicate a vertical compression. Basically, what that means is that everything is being compressed vertically. This parabola is wider than its parent graph would be. If you were to do the parent graph up here, it would be located at 0, 0 for the vertex, and it would be significantly steeper than the graph that we're looking at. So not only did we see a vertical reflection because of the negative, but we're seeing a vertical compression because of the 1/3 multiplier. That's every single transformation that's taken place on that function. We've got our sketch, we've got our checklist, we've got our problem solved. Let's go ahead and turn the page. We'll move on to problem 3. Here they're asking us to evaluate the piecewise function at the given value of the independent variable. The independent variable, of course, is x. So notice in this function, it tells us that f of x is either equal to x plus 1 or negative x plus 1. And that's just going to depend on what our x values are that we're evaluating. So if the given x value is more than 4, make sure you're plugging into the top piece of the function. If it's less than or equal to 4, you want to make sure to plug into the bottom piece of the function. Let's start with f of 8. So notice the x value 8, that's more than 4, so I'm going to be plugging into the top piece of the function. Once you understand how the piecewise function works, then it's actually pretty easy. I'm just plugging 8 into the top expression. 8 plus 1 equals 9 for the final answer. Likewise, for part 2, find f of 1. Notice here the x value that we're given is less than or equal to 4. So in this case, we want to use the bottom piece of the function. So that gives us a negative, and then in parentheses, 1 plus 1. Just put x, that x value, right into the function. You simplify, you get -2 for your output. Finally here, they ask us to find f of 4. Now when you look, that's kind of the breaking point in the piecewise function. This is when it's really important to understand and look for which of these has the or equal to option. And so notice the bottom piece, x less than or equal to 4. So we're still going to be plugging into the bottom piece of that function. So that's negative, parentheses 4 plus 1. Pardon me. And that's negative 5 for the final answer. So that's just evaluating a piecewise function. Really, it's just understanding the notation and knowing whether or not we're using or plugging into the top or bottom piece. Now, we'll extend that a little bit further by looking at problem number 4. Here they're asking us to graph the actual function. Now what I would highly recommend for this is to go back and use a basic graphing method, which is just constructing XY charts. The difference, or the catch, is you're not just going to construct one XY chart, you're actually going to construct a total of 3 of these. Because I'm going to construct an XY chart for the top piece of the function, for the middle piece of the function, and for the bottom piece of the function. And if you look at the definition in the function, it will tell you what x values to use for each of these pieces. For instance, in the top piece, your x values should go from negative 8 to positive 4. We don't need to use every single one of those, right? That's a nice simple expression. This is just going to be linear. So I would recommend using negative 8, maybe negative 4, 0, and then end at positive 4. Now here's an important detail. Notice that when x is positive 4, there's no or equal to on that end of the interval. That means when we graph it, that point is going to show up as a hole on the graph. It will not be an actual filled in solid point, but rather a hole. So let's go ahead and take the x values, plug them into the top piece of the function. Negative 8 plus 2 gives me negative 6 for the output. Negative 4 plus 2 is negative 2. 0 plus 2 is 2. And finally 4 plus 2 is 6. Now keep in mind, we're going to have a hole at that location, not an actual point. Let's go ahead and plot all of these. So negative 8 and negative 6. That's the first point at the graph. That's where the graph will begin. That's a solid point. Next, I have negative 4, negative 2. I have a point at 0, 2. And I have a circle located at 4 and 6. So that's an open circle on the graph. Let's go ahead and draw in a nice straight line. And then we'll move on. So the details I'd be looking for if I'm grading that portion, it's got to be a straight line hitting the correct points, solid point on the left, open point on the right. For the middle piece of this function, it's only valid for one particular x value, that's 4, and that generates one particular y value, that's negative 8. So I'm going to go ahead and plot the point 4 and then negative 8 down here. Finally, we have the bottom piece of the function. This is used anytime x is greater than 4. Again, you don't need a ton of points because this is a linear function. It's a straight line. So let's go ahead and start with 4. You could then check any x values that are bigger. Now this one does not have an upper limit, so that's why I put the dot, 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 just to remind myself or to show that that's going to continue on indefinitely. If I plug 4 into this piece, it becomes negative 4 plus 7 makes 3. Plug in 6. Negative 6 plus 7 is 1. Plug in 8, you'll get negative 8 plus 7 is negative 1. Now, that's going to continue on, so I will not put a stopping point on that end. I'm going to put an arrow. Also, keep in mind, because this 4 does not have the or equal to, that point at 4, 3 is going to show up as a hole on our graph. So let's go ahead and plot this information. 4, 3, that's the location of another hole. 6, 1 is a point. 8, -1 is a point, and that's going to continue going down to the right indefinitely. So I'm going to go ahead and draw in that nice straight line. I am not stopping. I'm going to put an arrow here. Now, when I'm looking for a problem like this and I'm actually grading and looking for all these key features, basically what I'm looking for is, do you have the straight lines positioned correctly, right, and hitting the appropriate points? For this first line segment, it needs to stop with a solid point on the left and an open point on the right. For this right-hand side, open point on the left, arrow going down to the right, and then of course that middle piece is just one particular point. So that overall end graph has a lot of little details to make sure you're getting right. But the nice thing is it's really just constructing XY charts to fill out those points. Let me go ahead and turn over to page 4, and we're going to continue on here. So I'm at the top of page 4. This is problem number 5, where they tell us that for these given functions f and g, find the indicated composition and simplify as much as possible. So they tell us here that function f of x is 12x squared minus 9x, while g of x is 8x minus 10. They're asking us to find f of g of 6. I like to write it nice and big because I use that expression to actually do the work. So I'm going to start by taking 6, plugging it into the g function, and generating an output. I'll show you the calculations here in my calculator. Let me get back to the home screen. So I'm plugging 6 into the g function. 8 times 6 and then minus 10. That gives me an output of 38. I'm going to jot that down. So 6 goes into the g function. It produces 38. That output now becomes your input for the next function in the sequence. This is how we'll actually produce our final answer. So you're going to take 38 and plug it into the f function. You're getting 12 times 38 squared minus 9 times 38. Let's go ahead and simplify. So again, I'll show you the calculation just to make sure everything is clear, but I've got 12 parentheses 38 squared minus 9 parentheses 38. When I hit enter, I'm getting 16,986. That's our final answer, 16,986. So remember that function composition, you're applying a sequence of functions from right to left. All right, let's go ahead and move on. For problems 6 and 7, they're telling us to solve the equation by the method of your choice. State your solutions as exact answers. That means no decimal approximations. If it's a square root, leave it as a square root. I'm going to start with example 6, or problem 6, by reminding you of what is called the square root property. The square root property is useful anytime you have something squared equal to a constant. It allows us to solve just by taking the square root of both sides of the equation. Of course, taking the square root of a square, that cancels, leaving us with just 2x plus 9. On the right-hand side, I have to make sure to consider positive and negative options. And the square root of 64 is just 8. Now, let's go ahead and solve for x. Follow your normal steps. I'm going to subtract 9 from both sides, so 2x is equal to negative 9 plus or minus 8. And then for the last step, let's go ahead and divide out the 2 on both sides. So x is equal to negative 9 plus or minus 8 over 2. Now, they ask us here to state exact answers. So you want to play this out. There's 2 solutions here, right? That plus or minus means you do both of those things. So I'm going to start with negative 9 plus 8 over 2. And the other solution is negative 9 minus 8 over 2. You can simplify each one of those as much as possible. So this is negative 1 over 2, or negative 1/2. Here I've got negative 17 over 2, or negative 17 halves. And those two x values are our final answers. All right, moving on to problem 7. The first thing I would recommend here is to get rid of the fraction. You can do that by putting that entire equation in parentheses or brackets and multiplying throughout by 12. So think of multiplying each of these terms by 12. When you do that, you're going to generate some nice canceling. 12 times x squared over 12 causes the 12s to cancel. That leaves you with just x squared. Next, 12 times x, so that's plus 12x. Next, 12 times 13 over 12, again the 12s cancel, leaving you with 13. 12 times 0 on the right is equal to 0. Now I'm going to solve this quadratic equation by using the quadratic formula. I'll remind you that quadratic formula, x equals negative b, so negative 12, plus or minus the square root of b squared, so 12 squared is 144, minus 4 times a, which is 1, times c, which is 13. In the denominator, you double the a value, so 2 times 1 is 2, and now we're ready to simplify. Always start inside the radical. So in my calculator, I'm going to type in 144 minus 4 times 1 times 13. And that's giving me 92 for inside the radical. So let's go ahead and jot that down. You've got negative 12 plus or minus the square root of 92. And that's all over 2. Now to simplify, and this is where it said no decimal approximations. So you're going to leave it as a radical and just reduce as much as possible. 92 is not a perfect square, but it's divisible by 4, which is a perfect square. So let's go ahead and do that factoring. Negative 12 plus or minus the square root. I'll show you the calculation here. So if you take 92 divided by 4, that leaves you with 23, which is a prime number. That doesn't break down any further. So I'm going to break down the 92 as 4 times 23. And now just take the square root of each factor. So this is going to become negative 12 plus or minus. The square root of 4 is 2. And then you'll have that 23 staying inside the square root. In the denominator, you've still just got 2. Now to reduce this, you've got 1, 2, 3 factors that are all divisible by 2. You can reduce this all or nothing. Either all 3 of these terms are divisible by the same amount, or you just leave them alone. In this case, dividing each of these by 2 gives us our simplified final answer of negative 6 plus or minus, this is a 1, this is a 1, square root of 23. And I'm totally fine with you leaving your final answer written that way. If you write them as 2 separate answers, it's negative 6 plus square root of 23 and negative 6 minus square root of 23. All right, I'm going to go ahead and show one more example here, one more problem, and then I'm going to stop, and that's going to be the end of the part 1 video. I'll pick up with the rest of the problems for the part 2 video. So on problem 8, they tell us that the graph of a quadratic function is given. The parabola has its vertex at negative 1, 1, and its y-intercept at 0, 2. Determine the function's equation. The best and easiest way to do this is to actually start with that equation written in vertex form. So as a reminder, the vertex form is written as y equals a parentheses x minus h squared, and then plus k out at the back. Now what's so useful about this is you can identify h and k simply by looking at the coordinates of the vertex. In this case, h is negative 1 and k is positive 1. Let's go ahead and plug all that in. So y equals a parentheses, x minus negative 1 squared, and then plus 1 out in the back. Now, of course, minus negative, that's just a plus. You could go ahead and simplify if you haven't already. So that's x plus 1 squared plus 1 out back. The only thing left for us to figure out is this value for a. That's where the other point, this y-intercept, is going to come in handy. Now, that doesn't tell you h and k because it's not the vertex, but it does tell you some values for x and y. We can plug those in to our current equation, and that's going to allow us to solve for a. So let's go ahead and make those substitutions. The y value is replaced with 2. And then in parentheses here, the x value is replaced with 0. And then we're going to solve this current version of the equation for a. Just simplify everything the best you can, starting with the fact that you can subtract this 1 over to the left. So take the 2 minus 1. That's 1 equals a times 0 plus 1 is 1, squared is still 1. So notice when all is said and done, 1 is your a value. And now we're ready to write our final answer. Remember, everything comes from the vertex form of the quadratic equation. So I'm just going to use that vertex form. We now know that a is 1, h is negative 1, and k is 1. So we're able to put all of those constants exactly where they need to be for our final answer. I'll write the final answer as y equals 1, parentheses x plus 1 squared, and then plus 1 out back. And that whole thing makes up our final answer. The one that I wrote out in the front is actually optional. If you leave that off, that would be fine. I'm just putting it there to emphasize that that's the a value. All right, that's going to do it for part 1. I'm going to stop the video here. I'll pick up with problem 9 on the part 2 video.